All right, so we are back talking about Chapter 9 here with our lecture on um, Chapter 9. So we have gone through more in terms of how we get the cold roll strip and how it comes into in coils or sheets. So after annealing. So now we're going to talk about what most of us are a little bit more familiar with, whether we're doing the actual fabrication work or the machining or the welding, the actual work that gets done on this metal once it gets to us in its form. So the forming operations for strip and sheet, of course, include bending, stretching, drawing, coining, and ironing. And that is a vast majority of very highly automated processes and extreme machines with a lot of other types of punch presses, rolling dies, progressive dies, you name it, to get the different types of product that we need using these sheet goods. Now, of course, in all of this, there are bending stresses that the material takes on that do affect the elastic limit. We are kind of trying to permanently change the shape of that metal. So, and in the process, while we try to bend or stretch or draw it, sometimes the material can kind of want to return to its original shape, or we're basically putting stress into the material, and sometimes that stress uh, continues to want to make changes to the material as well. So, those of you who are involved in fabrication, or those of you who have kind of talked about or machined and fabricated the sheet metal tool tray, know and understand as we use the press brake to bend that. So, especially if we're bending at 90 degrees, oftentimes when we bend to 90 degrees and then release it, it pops up and is open. The sheet metal is still at a greater degree. So sometimes we have to overbend a little bit to make sure that that stays at 90 degrees as well. And of course, that's what we refer to as spring back in the actual material as well. So, and we have to pay attention to that. So here's an example of that press brake. So we overbend slightly to allow for that spring brake, and of course we would have to adjust for that. If that product after we bend it, so it needs to still go out and have some different properties or annealing or heat treating other things after it's bending, we could again face the fact that it might have some spring back in it. And of course, as we bend it, so especially if we bend it too far, we might get different types of cracks. There are minimum and maximum radiuses that we can bend that to, so we have to pay attention to all of this. And of course, those bend radiuses are largely depending on the gauge of the material or the thickness of the sheet that we are trying to bend. So forming a sheet by stretching. So we can also stretch sheet goods over mandrels or over different types of dies as well. So that's going to increase the surface area and of course reduce that thickness. So some of the examples of this, oftentimes your steel cans, or even your aluminum cans, can often be stretched over different types of forms as well, and we have to pay attention to how that stretching is done. We're starting with different thicknesses, and of course we account for the finished thickness at the end in those processes as well. So drawing, so here's another example of a drawing. So where you can basically put a sheet, pull it into a die cavity. So, and then you are basically using material to kind of, or punch to more or less be forced into the material, and the material to kind of be pushed back up over that particular shape. So a lot of things are actually drawn over that material as well. So in the case of your aluminum cans, there are what we call drawing dies, and those do basically move over and are utilized in that way. As we have these forming tools, it's important to understand any defect or any variation, even something as a change in surface material or surface finishes can cause nicks or cause problems as we draw that sheet metal over there. And we can also get that material on the sheet to pick up on the tooling through friction, and that is also going to cause some problems as we are drawing and forming sheet in this way. So this kind of just goes through some of the mechanics of the metal. So with the dislocation between different atoms. So, and as we take a look at this, if you get into a company that's doing this a lot more, you will certainly be paying attention to the metal and the results after those parts are made and formed by these methods. So just some examples of some of the different things that you can do to prevent stretch or strain marks. So most of my experience in this has largely came down to the actual tooling and making sure that the tooling is maintained and kept up to specs and replaced when that tooling is worn out. All right, we also have a concept called coining. So coining stamps are punched into the flat sheet, so you've got a back plate there that helps to hold the sheet in place and helps to keep that sheet from kind of deforming. So if you've ever taken a punch and tried to press that sheet, we will kind of experiment a little bit with some punches and see what happens when we actually punch a sheet versus a actual coining punch that helps to hold that, and you get much better type results. So for those of you who are welders, if you think in terms of the iron workers in the welding shop, that would give you a good idea. Sometimes we can use the punch there in the iron worker, and it's a great way to kind of punch and get these coin shaped or holes out of it. We're still left with kind of the coin left over, but it also supports the material on all sides so we don't deflect or deform the sheet as well. This going to give you an idea of ironing. So once this is all very important in the formation of your soda cans and your beverages. So we'll watch a couple of videos on this just so you get a better idea here from that too. The company I used to work for, Crown Cork and Seal, has some great examples out there of how your cans and how the ironing aspect of making your cans kind of places and helps to basically support and strengthen the body of the can when it's being used. So drawing is another important process where, again, so we're just more or less pulling a larger diameter through a die into a smaller diameter, and that's what a process called drawing. So, of course, you do have to have this material annealed in order to be doing that. So your drawing dies are often made from tungsten carbide or diamond, so definitely a lot harder materials. So, and of course, some of those drawing dies that we're talking about are made from the blanks, what they refer to as the blanks, or the precasts, are done by powdered metallurgy. And so you get some of those drawing dies that are powdered metallurgy parts that then get precision ground to the tolerances that need to be made and held in that out of tungsten carbide. Some drawn wire for small springs, so just another application here so that we would be getting that. So now at the same time while that wire is being pulled and drawn through, it can go through a coiler and basically be turned and spun to actually get the spring shape out of that as well. So here's an example of a draw tube. So again, with a floating plug and your tube with the steel die, again, just a way to reduce that material and that tube as it's going through this equipment. We also have cold forging done in this. There are some differences between the hot forging process and the cold forging. So we do get a increase in strength, and the deformation basically is restricted. Largely, again, as we sit there and think about the microstructure of the metal, and as we forge this cold, it's breaking those microstructures. Oftentimes they're getting jumbled up. It's what they call a dislocation tangle. So I think in the textbook there's a pretty nice picture that kind of gives you a better idea of how the microstructure of these materials when they're cold forged would look. All right, now we're going to stop right there, and I will come back for the next part of this lecture where we talk more about joining and joining methods for steel as well.